So let's try to understand how Hamiltonian formalism can be used to understand central force motion. Okay, so let us first write the Lagrangian. So Lagrangian is T minus V. Now what is the total kinetic energy for central force motion? We have already done, so you can check it out. I'm just writing the result. It is half m r dot square. Okay, so this is the kinetic energy if the object is moving along radial direction. This is the kinetic energy with respect to the tangential motion, which is half m r square theta dot square minus the central potential. It may be gravitational or Coulombic, anything. Okay, so now what is the canonical momentum? Okay, let me write the general result. Pi is equals to del L by del Qi dot. Okay, we all know this. But what is I? I actually goes from 1 and 2. I equals to 1 means R and I equals to 2 means theta. Because you see, the Lagrangian here is a function of R and it's a function of R dot. It's a function of theta and it's a function of theta dot. Okay, so what is P of R? So P of R is del L divided by del R. So substitute the value of L and you will find it is equal to m r dot. Now what do you get from here? From here, what is P? P is or you can say like this. So you get r dot is equals to momentum along the radial direction divided by m. So keep it here. Okay, now let's find P theta, because we need these things to find the Hamiltonian. What is P theta? It is del L by del theta dot. So here there will be a dot. Okay, so let's see what do we get. When we do this, we get m r square theta dot. Looks like angular momentum to me. So from here you can say theta dot equals P theta by m r square. P theta by m r square. Anyways, this is not important. We are going to use P theta and PR to generate our Hamiltonian. Okay, what is Hamiltonian formulation? Hamiltonian formulation says H is equals to summation I Pi Qi minus L. But here I goes from 1 to 2. So what are the results? So you have PR, so Pi Qi dot. Okay, here. Okay, so PR R dot, and then there will be P theta theta dot minus L. You will see everything turns out to be positive. So you will have PR square divided by 2m. Then you will get P theta square divided by 2m, and you will get plus V of R. Why there is a plus V of R? Because this minus sign here makes this minus sign here plus. Okay, so once the Hamiltonian is found out, now we will look at Hamiltonian equation of motion. Let's see what is our Hamiltonian equation of motion. So first equation of motion says q dot, let me write it, qi dot is del h by del pi. Since I goes from 1 to 2, so this will generate two equations, one with respect to r. So r dot is equal to del h divided by del p of r, and this will give us what? It will give us p of r divided by m. And from here there is another equation for theta dot. So what is theta dot? Theta dot is equal to del H divided by del P theta. Del P theta. So what you will get? Here you will get P theta. Yeah, you will get P of theta divided by m r square. This is clear? This is the first part. And then we have the second part. In the second part, we have Pi dot is equal to minus del H divided by del Qi. Since I goes from 1 to 2, you will get two equations. Let's see. So first one is P1. P1 means PR. So PR dot equals del H divided by del R, and you will get this complicated expression, which is P theta square divided by m r cube minus dv by dr. Okay, so let's not focus on this. Let's focus on the second one. It's quite interesting. The second one says P theta dot. So rate of change of angular momentum with time is minus dh divided by d theta. Now if you look at the Hamiltonian, this is our Hamiltonian, that there is not a single term which is dependent on theta, because here P is a function of r dot and here theta dot is a function of P theta is a function of theta dot. So here you will have r dot square one term and here you have theta dot square. So you do not see any term in the Hamiltonian which is a function of theta. So this is 0. This is quite interesting. You see, one of the Hamiltonian equation of motion says that angular momentum is conserved. That is, the angular momentum under central force motion is not changing with time. So this is how you apply Hamiltonian equation of motions to the problem of central force.